Welcome back to our penultimate episode. In this episode, we are going to perform what feels like a miracle. We are going to take water apart. We're going to tear it apart and collect the bits that come out of it. Now, you can't do it with your hands, and it's too small. We need to understand scientifically what water is. Firstly, it's three atoms all together. Two of them are hydrogen, one of them is oxygen. That's why we call it H2, two hydrogens, O, one oxygen. Two hydrogens and one oxygen all stuck together. Hydrogen. That's the gas that has an explosive reputation. Okay, I'm not going to encourage you to make that much hydrogen. That's one I prepared earlier, especially for today. Those two ends of water, the hydrogen ends and the oxygen ends, carry a different charge. We might think of these as positively charged, the hydrogens, and the oxygen as negatively charged. Now that comes in useful if you think about your battery, because fortunately your battery also has a positive end and it also has a negative end. Now if that's the case, then each of our elements, the hydrogen and the oxygen, will be attracted to the opposite pole. Just a bit like a magnet, really. So the positive hydrogen will go to the negative electrode and the negative oxygen will go to the positive electrode of our battery. Now there is a way of doing this. It's very simple to just be able to take some water, for instance, and just drop the battery in. Do I want to do that? Well, that's all very well and good, but it's not thinking like an engineer, and that's what this one is about. What I want you to do is think about how you can get the electricity safely into the water so that we can then switch it on and off again. That's what these pins are for. Now the pins themselves, what are they made of? Yeah, they're made of metal, and metal is a good conductor of electricity. That's why we use metal cables, for instance. So what I want you to do is take your cup and I'd like you to insert the pins into the bottom of them. Now you notice I've got one in it, it's not in the centre. I need to think about where the other one is going to go. Okay, so I can guess there, it's just off the centre. So if I put the next pin about there and push that in, there we go, they're both in now. Now I don't know about you, but when you put pins in the bottom of cups, well, it leaves a little bit of a hole. So that's where your glue comes in. If you have a drop of glue, then you should take the glue and just be very careful as you dribble it down the back. Now don't get any on the top of the pin. Now it's going to set and cool really quick, so I'm going to push it in with the corner of my teaspoon. If you don't have a glue gun, don't worry. Remember I said you could use a bit of blue tack. Take a tiny little blue tack, push it, just wrap it around the inside of that pin and then push it home the rest of the way. That should seal the bottom of the cup really quite nicely. If you don't have any blue tack, then as I said, a bit of chewing gum, just take a little piece off just to seal up that hole. Now we're going to do the same with the other pin. I pull it out a little bit. I put a dribble of glue behind it. Bloop. And I'm going to push it home. Now that should have sealed my pins in nicely. That's just going to take a couple of seconds to cool down. So now I have two pins in the bottom of my cup and the actual sharp bits are on the inside of the cup. Now I'm going to add some water to this. Sounds sensible, doesn't it? We want to split water, so pour in some water. If I stand it on a battery now, the electricity should go into the water. Does it work? Well, no, it doesn't. Nothing actually happens. So let's think about this. Why? Well, hydrogen and oxygen make up water, but there's really nothing else in there to enable an electrical charge to be carried. So that's where your bicarbonate of soda comes in. So open up your bicarbonate of soda. It might be called baking powder. Just about 1/4 teaspoon. Pop it in and give it a stir. You want that to be dissolved nicely in there. So our next thing now is to line it up carefully on the battery so that each electrode touches one part of the battery. If you've done it right, and the electricity is going through the pins and into the water, then you should notice that there are two streams of bubbles. The one that has the most bubbles is hydrogen. The reason being is because it's H2, twice as much hydrogen as oxygen. So for every molecule of water we take apart, we get two atoms of hydrogen which join together to become what we call a diatomic molecule, just H2, and that's a gas. And then that floats up and they join together and become a bubble. O2 is also O2. Oxygen is O2. So it needs to take another water molecule apart to be able to make one diatomic molecule of oxygen. So we have to take twice as much water apart to make the same amount of oxygen as we do hydrogen. That's why we get twice as many bubbles. The other reason that we can say that that is hydrogen is because hydrogen, remember, we said was a positive molecule, and therefore it's travelling towards the negative end of the battery, and that will be marked on the side. The oxygen, on the other hand, is negatively charged and goes towards the positive end of the battery. Now, if you've left this on for a few minutes and you're still fascinated watching it, what else can you note? Do you notice that the pin around the oxygen molecule is actually turning a bit manky? It might not be the same colour that it was before. You might find that there are bits and pieces floating in the solution around it. Think back to the Bernie experiment. What did we burn in oxygen? Yeah, we burn iron. Have a guess what your drawing pin is probably made of. Yes, it's steel or iron, and therefore we are now putting lots and lots of oxygen around an iron pin. So we are making iron oxide. Yes, we're making it rust. So the colour that you can see coming through in your solution is probably just there because of the rust. If you leave it on long enough, it goes like orange squash. So there we have a way of taking water apart. This is quite an important part of science, is thinking about what things are made of and then thinking about how we can take them apart. So that's all from me from this one. In the next one, we're going to look a little bit more at water, but what I'm going to do is I'm going to finish on a cold note, and I'm going to show you how to freeze water instantly. That's all from me for now. I will see you later. Bye.